Alrighty, so let's take a look at what our learning targets are for today. Okay, we're going to talk about what's called a percentile. We're going to talk about something called a standardized score. You'll hear it referred to as a z-score. And then how do we use those two things to compare a distribution? So let's jump over here. Any Back to the Future fans in the house? It's my husband and daughter's favorite movie, by the way. When we went to Universal, she was most excited to take her picture with Doc Brown next to the DeLorean. So there you go. That was what she was most excited about. So let's take a look. So it references some characters from Back to the Future in this one. So it gives me a list of scores from the first chapter test. Ours were much better than that, by the way. Okay. Tells us that the mean is 80 and the standard deviation is 10. Now, it's been a minute since we've talked about mean and standard deviation. What does a mean represent? What is a mean? It's the average, okay? So the average score was 80, okay? Does anybody remember what standard deviation means? Yes, typical distance from the mean. Okay, so each score is pretty much distance from the mean, about 10 points from the mean. Okay, so that's what an average is. Mean is an average. Standard deviation is that distance from the mean. So it tells me that Biff scored a 60 on the quiz. What percentage of the scores are less than 60? So let's look at the list of scores. Okay, here's Biff's score. He's a 60. Wah, wah. How many of them are less than 60? Zero. Okay? Zero. And if I want to convert that to a percentage, the first thing I've got to know is, well, how many scores are listed right there? Somebody count them for me. 20. There's 20. And if I do 0 out of 20, that gives me 0%. So nobody scored less than a 60. Now, Marty, because he's a rock star, he scored a 90. Okay. What percentage of the scores are less than 90? All right. So let's count. How many scores are less than 90? 16 of them? Yep. Out of 20. Okay. And if I wanted to make that into a percentage, what would I do? I'd divide, right? And I'd get 0.8 and then multiply by 100. And what percent would it give me? 80%. What you just found was what's called a percentile. Okay, a percentile is the percent less than a certain number. Okay, so what we just did was called a percentile. Okay, it equals the percent less than, always less than, a given value. So there's our first learning target. All right, be able to calculate a percentile. And that's something we've been doing, we just didn't call it that. Okay, it's always the percent less. The percent less. Okay. All right. Well, let's go up here and let's talk about Biff a little bit more. How far away from the mean was Biff's score of 60 and in what direction? All right. What did Biff make? A 60. What was the mean? 80. And so if I want to know how far away 80 minus 60 gives me what? Would we say he's above the mean or below the mean? He was below the mean. Okay. So then the next thing it asked me was how many standard deviations is 60 away from the mean? Well, what did they tell me was my standard deviation? It was 10, and if I'm 20 away, how many standard deviations is that? It's 2. We would take our 20, which was our distance, and divide it by our standard deviation. And we would get 2 standard deviations. Okay, so he was 20 below the mean. All right, so let's do it for Marty. Marty's score was a 90. How far was Marty from the mean? He was just 10, right? He was at a 90. 80 was the mean, so he was just 10. And then how many standard deviations would that be? It'd be 1. 10 divided by 10 would equal 1 standard deviation. Okay, what we just found there, all right, is referred to as a standardized score. Okay, and I just want to kind of walk you through what we did to make that happen. This is our standardized score. All right, in both of these, we did the same process. Okay, we also refer to it as a z-score. Okay, so that's what we did in both of those. Right. Now, I would tell you that for Biff, his z-score would be a -2. Why do you think it's negative? Because he's below the mean. He was 2 standard deviations below the mean. Marty's z-score would be a +1 because he was 1 standard deviation above the mean. Okay, he was 1 standard deviation above the mean. The process that we're going to use every time, all right, to get a z-score is pretty much the same. All right, so let me kind of walk you through that process. So a z-score is nothing but how many standard deviations are we away from the mean. Okay, and each of them, what was the first step we did? Yeah, we subtracted to get how far away, and then what did we do? Yeah, we divided. Okay, and so our process to find a z-score is exactly that. We're going to subtract and divide. All right, and it's going to give me a z-score. So let's look at this one. All right, how far away from the mean is 97 and in what direction? So my score is 97. What was my mean? 80. So we subtract, and that would give me what? It's going to be 17 above. Okay. Now, this time we're not going to get a whole number, right? But if we want to know how many standard deviations, we take 17 and divide it by what? 10. And it would give me 1.7 standard deviations. Okay. What do you think my z-score is going to be? 1.7. Okay. So this is the formula that we'll use every time, okay, to find a z-score. We take our data point minus the mean, and we divide it by the standard deviation. Anytime we want to find a z-score, that's what we're going to do. We take our actual data point, all right? In this case, it would be our actual score, which was 97. We subtracted the mean, and then we divided that answer by how long the standard deviation was. Okay, and that's what we did in all three. Okay. So that's a z-score. All right. Z-scores are useful because they help us be able to compare data sets that aren't identical. Okay, and here's what I mean by that. Let's take a look at this very last situation. It says that Lorraine scored 1.4 standard deviations above the mean on her first biology test and 1.9 standard deviations above the mean on her first psychology test. Was her test score higher for biology or psychology? What do you think? Yeah, we're not going to know unless we actually have the mean. Because what if the mean on the biology test was 95 and she made 1.4 greater. But the mean on the psychology test was 45, and she made 1.9 higher. You see what I'm saying? Like, we have to know the mean. We can't tell right now. We need the mean to be able to compare. And so our final learning target is if I need to compare two completely different sets of data, we use a z-score to compare. Okay, so if we've got two different things going on and we need to be able to compare, make some decisions about that data, we're going to have to use a z-score to do that. Okay, so which means we're going to need a data point, the mean, and how long the standard deviation is. We're just going to need some stuff, right? So subtract and divide. That's what we're going to do today. All right, fair enough. That's my kind of math right there. All right, especially when I can use my calculator. All right, let's organize things really quickly on that back side with your notes, work through a few examples. Okay, so we'll be ready to work when we get back from lunch, so not terrible today. All right, are we good? Flip that over to the back side for me, please. All right, so here we go. Let's walk back through those learning targets. Learning target 1 was all about a percentile. Okay. A percentile is always the percent less than a given value. Always less. Okay. A percentile, always the percent less than a given value. Learning target 2 is my standardized score. We'll call it a z-score. Did y'all do a z-score in Algebra 2? Seems like I remember that got added. All right. So it's our data point or our actual value minus the mean. It's okay if it's negative, divided by the length of the standard deviation. Okay, and it tells me the number of standard deviations above or below the mean. Okay, and then learning target 3 was how do we compare things from two different sets of distributions? We use a z-score to compare data from different distributions. Okay, I do want to work through the examples here on the back of this page just because they're good, okay? Just because they're good. So learning target 1, get a percentile. It's the percent less than a given value. Standardized score, or z-score, all right? Value minus mean divided by your standard deviation tells us the number of standard deviations above or below the mean. And then finally, we want to use that z-score if we're going to compare data from different data sets. They're reading this book and everybody keeps dying. So she's got this question wall in her room, and I went in there the other day and I was like, how many more people have to die in this book? And that's what I put on her question. Yeah. All right, so let's take a look. So this is talking about the U.S. House of Representatives. It has 435 voting members. Each state's allocated a number of seats in the House based on its population when the census is taken every 10 years. A dot plot of the number of representatives from each of the 50 states in 2019 is shown along with their summary statistics. The red point on the graph is for the state of Ohio with its 16 representatives. Okay. All right. Now, if each one of these dots represents the 50 states, how many dots are in this dot plot? There are 50, okay? So that's why reading all that stuff in the beginning was important. It told me there's 50 dots, all right? And I want to find the percentile for Ohio and then interpret this value, okay? What did they tell me was Ohio's number? It was 16. And if I want that percentile, I need a percent of how many are greater or less than 16. Less than, okay? Percentile is always less than. And so if we start counting, y'all pray I get this right. Okay? Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Oh, that's smart. See, this is why I need help. All right, let's see. 1, 2, 3, 4, 5, 6, 7. All right, that are 16 or greater. So we subtract that, give me 43. Smart. See, this is why I got to have help. All right, so 43 dots on the other side, okay? There were 43 dots on the other side. And so if I want to make that a percent, what are we going to do? We're going to divide, and what do we get? 0.86. To make it a percent, we'll multiply by 100, and I get 86%, okay? Now, here's the tricky part, and this is where you'll have your pull-down menus within your assignment, okay? Let's interpret that. What does it mean, okay? It means that 86% of the states have more or less, have fewer or less representatives than Ohio. Okay, that's what it means. So that interpretation piece is important. If you've looked at your ACT scores when they come back on that report, if you dig down in that data, besides just your regular scores, it gives you percentile performances. Okay, so let's say you scored in the 45th percentile. All right, that means 45% of the people scored less than you. All right, on that section of the test. All right, so something to think about. So percentiles are a value that you will see statistically. Okay. Now, here's an interesting question. It says South Carolina is at the 52nd percentile of the distribution. How many representatives did South Carolina have in 2019? Now, this is a little bit trickier. Okay. Basically, what they want me to do is to undo the percentile. Well, how do we do that? Okay. So let's take that 52%, and if I wanted to convert it back to a decimal, what would I do? I would divide by 100. So I would take 52 and divide by 100, and what would I get? I get 0.52. Okay? Now, here's the thing, right? I don't need to go all the way back to a fraction. You could if you wanted, but you don't have to. What I want to do is to find out, of my 50 people, where does that 0.52 start? Okay, where is it at? How many dots does it take to be at the 52nd spot? All right, so we're going to multiply 0.52 times 50. Okay, I get 26 states. Okay, so 26 states happen before South Carolina. Okay, so this is where we've got to go back to the data, and this time there's no easy way. We just got to find the 27th dot. So I need the 27th dot, okay, because I got to be one more than what I just found. So let's look. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 21, 22, 23, 24, 25, 26, 27 would fall about right there. What number do you think it is? 7. Okay, they would have 7 representatives. All right, I think that is the trickiest problem we'll do today. Okay, because if you want to know, if you want to undo the percentile, okay, so make yourself a note. If I want to undo a percentile, convert it to a decimal, multiply it by your total number of data points, and then count to one more than the number you get. Okay, so it's got to be one more than what we get. So there would be 7 representatives. That's going to be the toughest one. Okay, and then let's do number 3 before we go to lunch. Okay. The last thing it says for me to do is to calculate and interpret the standardized score for Ohio. Okay, so let's just talk about that. We're looking for a z-score. All right, so we want the value for Ohio minus the mean of the whole data set divided by the standard deviation. So what was the value for Ohio? 16. Minus what was the mean for the whole data set? 8.7. It was right there in my summary. And divided by my standard deviation, which was what? 9.723. Now, you can do this on one step on your calculator, but you got to use that division, that fraction template, which is alpha y equals, all right? Otherwise, subtract first, then divide, okay? Subtract first, enter, then divide, okay? But you're going to need your calculator for that faux show, okay? So type it in. Let's see if you can get the right answer because it's important. A lot of times we'll mess this up just because we don't type it in right. You should get 0.751. Okay. So make sure you can get it typed in correctly. All right. You can always do alpha y equals, and that gives you the fraction template. And choose number 1. That gives you the fraction bar, so you can put the top on the top and the bottom on the bottom. Then just hit enter. But we should get 0.751. Okay. Otherwise, subtract first, enter, then divide, enter. Okay. Do it in 2 steps. All right. Now, what does that mean? Well, it means that the number of reps for Ohio is 0.751 standard deviations. Is it going to be above or below the mean? It's going to be above. If you get a positive answer, it's above. Okay? So again, in some of your drop-down menus, that's what they're going to ask us. All right, to interpret it. So the number of reps for Ohio is 0.71. Go get you some lunch. Standard deviation is above the mean.